key word up here is inverse. Anytime I'm going to suggest or tell you guys anytime on the January Regents we see that word inverse. I don't know. Did anything come to your mind right away? What do you mean by opposite, though? Can I get a little bit more detail than opposite? I don't like reciprocal. I don't like switch the signs. I do like switch, though, not the signs. Liz? Flip X and Y. Switch X and Y. All right? Anytime I see inverse, I'm going to take the equation they give me or whatever I'm doing, and I'm going to switch every X and every Y. All right? I'm going to switch the X and the Y. So go ahead, help me right now. Take this equation and switch your X and your Y. So it's going to start off now with X equals 1/2 Y plus 8. And then most of the problems, like this one, you're going to be required to now solve for Y. Get Y by itself. And that's what you and your partner are going to discuss right now. How do I get Y by itself? Go ahead. Get Y by itself. And make sure your answer is up there somewhere. What are you guys doing first? Moving the 8 over by subtracting it. So we should have X minus 8 equals 1/2 Y. All right, now here comes the sticking point you may have trouble with. How do you get the 1/2 out of there? Now, you could divide by 1/2. That's always correct. I just don't know what you're going to do from there. All right, but so the easier route and the route I'm going to take right now is multiply both sides by 2. Multiply both sides by 2. And be careful here. Regents is tricky. Make sure you multiply everything by 2. Because take a look, you just do 2x minus 8, they're sucking you in by choice 1. All right, so this will be y equals 2x minus 16, yes. Make sure you multiply everything by 2. That's why choice 1 there. Tell you, the people who make these things are dirty. All right, they know every single mistake you may make, and they're going to suck you in. Any issues there on 6? Okay, 7. What's the answer, basically? What's the value of x? This sounds like a broken record. The answer is there somewhere. The answer is there somewhere. I'm not expecting you to solve it. What am I expecting you to do? Store them, plug them in. Yep, store them, plug them in. Now, this one's a little different because you have x's on both sides, so I'll talk about that right now, but at the beginning, everyone get 5 stored in for x. Get 5 stored in for x. Okay, now what you're going to have to do in your calculator is you're going to have to type in the left side, and then next step, type in the right side and make sure those things are equal. If they are equal, that's a solution. So here's what I'm talking about. We do square root of x squared, what is it, minus 4x? Minus 4x plus or minus 5? Minus 5. See what that gives you. So I get 0. Now type in the right side, which is what, 2x minus 10? If they're the same, got a solution. 5's a solution. If they're different, that was not a solution. So at least you guys know 5 is the solution. Go through the other 2 right now and see if they are or not. We know 5's a solution. What about the other 2? That's listed in the multiple choices. You got to know how to use it and get used to it. What are you guys finding? 5 and 7 work. 3 did not. Okay. Questions there? One more. Go quick. I'll let you read through number 8 about Stephanie and her white wing crossbills. What are... never mind. It doesn't matter. It doesn't matter. It doesn't matter. Focus on that, getting that 36, getting that 26 points. There's a lot of stuff up here that's made to get you confused and feel bad about your math ability, which it shouldn't. They give me this equation up here. T is time. And they want to know which one basically matches it down here. Okay, which one matches it? Not expecting you to solve this one either. How many variables are in the equation? 1, T. Pick a number for T. Ian, pick a number for T. 2. Everyone plug in 2, please, for T into the original one. 550 times 1.08 to the second. Everyone see that number on your calculator? Take each multiple choice and plug in what now? 2. Keep plugging in 2 and see. You're not going to be exact, but you're going to come pretty darn close. So go to each multiple choice, plug in 2. And which one do you get almost the same? You don't get style points on multiple choice. You get survival points. All right, there's no style points here. That's parts 2, 3, and 4. Which one comes pretty darn close? It's raised to the 12T. Yep. And guys, I'm going to get animated here about this. We have done 7 review problems this week. 7. 3 of them out of the 7 have involved solely knowing how to use your calculator to get away with it. 3 questions times 2 is 6 points. You need 20 more points to get that 65. And we haven't even, we're not even in the double digits yet. All right, as far as the question numbers. All right, 3 out of 7, just knowing that darn calculator. All right, we're going to get through this. Okay, we'll get through this. Questions at all? Okay, now about the present. You have a quiz tomorrow. All right, on probability. I'll make it easy for you. It covers yesterday and today. That's it. Okay, it covers yesterday and today. So what I mean is, are they independent or dependent? Mutually exclusive or not mutually exclusive? And then actually finding those probabilities. So, tomorrow I'll give you the colored pencils. And I'll say, I take a yellow out and I don't replace it. What's the probability I get another yellow? Is that independent or dependent? Can you find that probability for me? What else did we have? Oh, the or one. What's the probability I take science or language, where you had to subtract out the people who had both? And we're going to do more of that today. And then what we do today is also on there. Okay? So as I talk about yesterday, do you want me to answer any questions from yesterday's assignment? Maybe as a quick little review, or you just had questions in general. I'll take those right now. Yesterday's assignment before I get into today. Mary, you're up. 9B. The probability will land the same way each time. Got it. And how many times are we flipping this bad boy? 4 times? Okay, so the probability it will land the same. What could be the same way every time? All. It could be all heads, right? So the probability of 4 heads, like 4. Never mind. All right, never mind. Or 4 tails. So these are the only 2 ways it could be the same way, right? Okay, let's do 4 heads first. Flip the coin. What's the probability you get a head? 1/2. Flip it again. Second time. Does this first time have any effect on the second flip? So what is it going to be again? 1/2. Keep going. 1/2 and 1/2. And how many times are we flipping the coin? More than 2. 2 or more, right? So do I add them or multiply them if it's multiply when it's 2 or more times? Yep. And then guess what it's going to be for 4 tails? Same thing. So for 4 heads, it's going to be 1 out of 16 shot. All I did was multiply numerators and denominators, and same thing for 4 tails. So in total, it's going to be 1/16 for the 4 heads, 1/16 for the 4 tails. So total that it could come out the same, 2 out of 16, or if you want to reduce it to 1/8. Saw some other paws up. Hi, Aria. Good idea. All right, you got it. Good question. Let me get to that section. Okay, here you go. Shoot. All right, a 2 or a queen. So here's what you have to ask yourself. You have a deck of cards in front of you. Can you get a 2 and a queen on the same card? Can you do that? You know your cards? Can't do it, right? It's impossible. Everyone else agree? You can't pick a card out that's got a 2 and a queen on it. So that's why these would be mutually exclusive. They cannot happen at the same time. So that would be mutually exclusive. Can you get a card with a 7 and a club on it? Yes, you can. So these are not mutually exclusive because they can happen at the same time. And then what about a spade and an ace? Can that happen at the same time? Yes. So these are not mutually exclusive. All right. They're only mutually exclusive if they cannot happen at the same time. All right. Good question, because that'll be on there tomorrow. And also finding the probability of it. Others? Anything else you want me to touch upon for going in tomorrow? Whew. Hold on 1 second. I have a gut feeling I'm going to have you do a tree diagram or a sample space. Nope, never mind. We're good. Nope, that's good. No tree diagrams or anything. Okay. By the way, nice question that Mary just asked. Just throwing that out there. But maybe not. I won't flip it 4 times. Oh, now you have a question. Why did I add them? Okay, because we had 4. I'll just do this quick now. The probability of 4 heads came out to be 1/16. The probability of 4 tails came out to be 1/16. Right? Okay, well, this is one probability of 4 heads, another probability of 4 tails. In total, what's my probability? 2 out of 16. So because I'm finding the total probability here between the two, I want to add them together. But the same way, I want it the same way. Okay, here's 1/16, I agree, but it could also come out the same way another way, and that's the tails. I need both ways. If I wanted one in, I would have asked it just like I did in part A, which is what's the probability it comes up heads. Okay? Yeah. Yep. Okay. Here's why. Which of the following probability outcome was less than 3? All right, Langston, how many are less than 3 on a die? Out of 6, right? How many are even on a die? The number 2 on a die. I counted it here because it was less than 3. I also counted it here because it was even. Can't count it twice. So that's why I needed to subtract out that 2, the number 2 on the die, because I'm counting it twice here and here. Good? Good question. Anything else? Hi. 10? Now we're getting fired up for this quiz, huh? I got to get to today's stuff too that's on there. I'll keep going here. Ready? 9 girls. I got to see the number. 7 boys. Alphabetical. Beautiful. What's the probability 3 girls first enter the room? Ready? How many girls are there? 9 out of? What are you doing? I'm just, wow. All right, I'm going to pretend I didn't see that. 9 out of 16. That whoever goes first can't go second and third, right? So how many girls are there now? 8. And how many kids? Still 15, right? And now I got to go to the third spot. Say, you know, these 2 girls, whoever you pick, can't be in the third spot either. So how many girls do I have? 7. And how many kids? 14. And there's 3 kids, right? Which are more than 2. So I got to multiply those probabilities. So this is the first girl, second girl, third girl. Okay. Want a little challenge now? Yeah, you do. Well, that was a challenge anyway, but all right, let me say, ready? Let me get rid of 2 girls, then the third one's got to be a boy. What are you going to put here now? Nice job. Got it. Good. Everyone all right? Okay, ready for today's stuff. Today is reading the table to get to the probabilities. You and your partner right now, can you do 1 and 2 for me? I'm starting it right off the bat, not teaching a thing. Using that part, I'm sorry, excuse me, I meant 1A and B. 1A and B, not 1 and 2. 1A and 1B. Can you read a table to find the probabilities? Probability you get 2. How many 2? How many have 2 pets? 33, and then you got to do a little adding. Out of how many customers? 100, yep. 33 out of 100. At least 3, what's that mean? At least 3. 3 or more. So wasn't just looking at the 18, I was looking at the 9 as well, for a total of 27 out of 100. Okay, no big deal. Reading the table. At least 3 or more. Ask away, because now the tables are going to look a little bit more complex. Now we're going to deal with what we call a two-way table. Info on the left, info on the top. Here we go. Here you go. 52 seniors. Here's what they're doing after they graduate. Some are going to college, some are not. Male, female, we got it. Probability you pick a person at random that would be female and going to college. So can we read this table correctly, and you find me how many people are female and going to college? Anybody locate that number on the table? How many of them are there? 13 right here. Going to college, female. 13, but it says probability, so it's got to be out of a total of, it's a person. I'm probably that a person. How many people are in this survey? 52. Yep. 13 out of 52. If you want to reduce it to 1/4, you can. I'll accept both tomorrow. All right, how many people can I stump on this next one? Come on. Probability you pick a person at random, female or going to college. Different from Part A. Part A, they had to be doing both. Now they can be female or going to college. So here we go. Probability they're female. Read the table correctly. How many females do I have here? 22 out of 52. Or they could be going to college. Regardless of gender, we're going to college. 29 out of 52. Anybody want to speak up here? Anybody want to speak up? Because I'm not done yet. Jason, speak up. I've counted some females twice. All the females going to college, I've counted here because they're female and here because they're going to college. So yes, we need to subtract out. How many are doing both? 13 out of 52. And yes, I'm going to be adding these up because I'm only picking how many people? One person, remember. If I was picking 2 or more, I'd multiply, but I'm only picking 1. In all seriousness, are we okay on doing this calculations with or without a fraction template? So what's that, 38 out of 52? And if you reduced it, I don't care if you do or not, 19 out of 26. Okay, all good. Only thing I'm going to do for number 3 is I'm going to take away that total column on you now. Hey, DJ, live band. All right, at the prom, DJ, live band. What's the probability you select a student who wanted to have a DJ? Doesn't look like gender matters, so ready? How many people want a DJ? Not your personal opinion, from the table. 237 out of, remember this is a randomly selected student, so how many students do I have here? 435. Yep, 237 out of 435. Ask now if you don't know, because they're going to get a little trickier where those numbers came from. All right, B, you select a student that is both male and wanted a live band. It's got to be both, right? With that and in between, both male and a live band. How many of them exist? Male and a live band. 103 out of how many students again? 435. All right, I think we're getting better at this. C, you're going to have to go back to the table. I apologize. You select a student that's female or wanted a DJ to perform. Not both. I would have put the word and in between them. I need a female or a DJ to perform. All right, female. 230 out of 435. What about the D? How many people want a DJ? 237. Anybody want to pipe up here? There's a couple people I've counted twice. I've counted the females who want a DJ twice, so subtract out 135 out of 435. Yep. Can't count them twice. Okay, I'm randomly selecting a student here, so I'm going to add those. If I was picking 2, 3 students, then I'd multiply all those probabilities, yes. But if I'm only picking once, Grace, I'm just going to add them. What are we getting there for C? 332 over 435. Who can I get on the next one? Probability you select a randomly selected male wants a DJ to perform at prom. A randomly selected male wants a DJ at prom. Well, how many of them do I have? How many males want a DJ? Okay, I got that. But I hate to break it to you, it's not going to be 435 on the bottom. Why 205? Because this is a randomly selected. So now you're looking at only the, because take a look at the previous problems, guys. You did a randomly selected student, randomly selected student, student. Now I'm decreasing that to only the males. So it's not out of 435. You are correct. It's out of 205. Yep. Everyone all right? Why my denominator changed? Going? We all right? Okay, I got good news for you. Maybe. Now I'm going to actually, instead of you guys doing the probabilities, I'll put it right in the table for you, what the probability is. Okay, so for instance, grade 9, you got a 0.29% or 0.29 chance, 29% chance you're in grade 9, 26% chance you're in grade 10, etc. I'll be honest, I want to go, I know this has nothing to do with what you're going to need to know. So can you just put an X through whether it's random or not? Don't worry about it. Trust me. We're just wasting time right now. Just wasting time. Here's what I need you to do. Fill out your own two-way frequency table. Okay, fill out your own two-way frequency. So I will give you 2 to 3 minutes right now with your partner or partners to see if you can fill out that table and answer parts A, B, and C on your own. I'm not going to give you all the numbers you need, but the numbers I give you can lead to the missing ones. Here's what I'm going to need you to do is fill out your own table. Once you get your table filled in, try to answer parts A, B, and C. Okay, be careful, Gabe. I see what you're doing, but did I ask for the probability? See how you're giving me the probability? I'm just asking for how many. Okay. Good, good. Keep going, guys. Keep going. Nice job. Didn't even have to show you. Okay. How many total students? What do you have in there? Total students. 150, right? Mm-hmm. That's how many total students. And here, you're giving me the probability. You see the word probability at all? No. I just need to know the number, okay? How we doing, ladies, all right? Okay, we good? Only if I ask for probability. You put it over that fraction. Okay, good. Nice job, everyone. All right, we don't have to go over much there. All right, 150, 78, and 38. Yep, how many? All right, now what I want to do. All right, you can flip it over. Go ahead. And I'll just stay on my slide here. Here's what I want to do. This was called a two-way frequency table right here, a two-way frequency. Why two-way? There's stuff on the left, stuff on the top. Now I want to transform that into what's called a two-way relative. What's it called? A relative frequency table, which means instead of the number 32 here, I want the probability that they're freshmen and attending. All right, now you're going to insert the actual probabilities. So for instance, this is 32 out of what that are freshmen that are attending? 32 out of? No. This is all students here. 32 out of 150. Everybody go to your calculator right now. 32 out of 150. You're going to get a nice decimal in there. And that's why I asked you to round to nearest thousand. So 0.213. So that's what's going to go in the freshman attending. 0.213. How about sophomores attending? And then I'll let you go on your own. You're going to put the probability 46 out of 150. Go ahead. Shoot. 46 out of 150. 0.307. Okay. I'm just looking. I should have done better. Should have just went somewhere else, right? Now, real quickly, what should be in the bottom right-hand corner under the totals? 150 out of 150? Well, yeah. And hopefully, it adds up. Once you find it, everything should add up. Go ahead, finish it up. When you go up and down and when you go left to right, it should all add up to the totals that you have there. Everyone's matching up. Just make sure your totals match up. You know you're good. I have the wrong ones, so don't ask why, Mary. You're welcome. Everyone all right? All good. So two-way table is when I just fill in the numbers. A relative frequency is when I find the probabilities and plop them in, because you'll have one tonight to do. All right. Let me put it. The two-way frequency is yes. I am going to give you just here you go, just like number 5. Okay, where I'm going to give you info, you got to fill in your own table, and I may ask a couple questions. All right, but I didn't go as far as this probability stuff. All right, last one. This guy's on fire today. Okay, I don't want you to read through the top because honestly, we don't have time to read all through. We can go right here. The probability that you randomly select a student at this high school that has asthma, 0.193. Where should I put that 0.193? Probability a student has asthma. Where should I put that 0.193? Total, yeah. Total has asthma, 0.193. And the question is now asking, what other one can you find now? What other probability? Now that you know that 0.193 in the total, what other probability can you find up here? I can have what? You can find the probability that student, which other box can I fill in? Student does not, yes, student does not have asthma. Yeah, you can find it, but I don't think it just said what other probability. All right, ready? Part B. Probability you select a student who has at least one household member who smokes is 0.421. Can you figure out where that 0.421 must go? At least one household member who smokes. Where should that 0.421 go? Total for at least one, right? So right here, everybody. Given that one, what other probability could you find on the table? No household member smokes, yep. And again, it's not asking you to find it, but, and then one more. In addition to the two I just gave you, student has at least one household member who smokes and has asthma is going to be 0.120. Can you put that 0.120 somewhere? The student has at least one member who smokes and has asthma. Everyone see where you're going to put that? Yeah. Right here, I hope. Point. All right, now using all three, because it said using the previous ones too. Which one can I find? Which one or ones can I find now? I can find doesn't have asthma and one who smokes, right? So I can find doesn't have asthma. ASTHMA. Doesn't have asthma and one member who smokes. Is there anything else I can find other than that? Basically the rest of the table. Actually, no, I couldn't find the rest of the table. I can? Okay. Calm it down over there, right there, smarty pants. So just rest of the table. Two things I want you to, can you go to the assignment, please, for tonight? Because I will never have you make up your own two-way table. I will always have one provided for you to fill in. And I don't have that for 3 and 4, so I want you to copy down the table for 3 and 4. So here's the table for 3 that you can fill in tonight. Little male, female, yes, no. All right, so that's the table that should go into number 3 that you're going to fill out. If you're working during the holiday or not. And then just turn over to number 4, and I'll give you that one. Everybody good with 3? We're good. I can go on to 4 because I got about a minute left. 4's pretty big. 4 is pretty beastly. I got company. We got potluck. We got let's go to the restaurant. Let's just do a gift exchange. And then let's do a total column. And then we got managers. What other ones we have? We got staff, assistants, and total. And then part B is the same table, but just with the probabilities put in there. All right, so just make sure you have those. And I'll answer any questions you have before the quiz tomorrow, and we'll get after it. Have a good one, guys.